Hello, in this video, we are going to see about configuring kubelet. The prerequisites would be to have some good understanding of kubeadm, kubeconfig, and JSON path. Kubelet is an important software component of the Kubernetes system, and kubelet is present on all the instances of the cluster. So it means that kubelet is going to sit on masters as well as the worker nodes of the cluster. So we have a kubeadm based cluster in the system, and let's now look at the number of nodes in this cluster. So we have got two, one is the master and one is the worker node. And if we have to see, we are already on the master, and if we have to see some details about kubelet, which is on this master instance, we could give the command sudo. Even before that, let's see where the kubelet binary is stored. Because with kubeadm, if you have launched the cluster using kubeadm, kubelet is going to exist as a binary in the Linux system. So if you give which kubelet, you're going to find the path of the kubelet binary, which is user, binary, and kubelet. And this kubelet has to run all the time like a background service, like a daemon. So it has to run all the time. So it runs as a service in the background. Let's look at some details about the kubelet service. So for that, I'm going to give sudo system control status and kubelet to look at the status of the kubelet service. I'm going to hit enter. Yeah, so this tells me that this kubelet service is active. And if I have to look at the configuration of the kubelet service, I'll have to look at this file in this path, so which is here. I just highlighted it for you. So let me just go ahead and look at the contents of this file. So let me just copy it to ensure I'm not going to give any typo errors. I just copied it. Okay, and now let me try to cat it. So this is the directory. What I copied is the directory, and I'll have to give the file name as well, which is nothing but 10-kubeadm.conf. So the file name is also given here, right? So this is the file name. So I'm just going to hit enter right now. And I see a few things about the configuration. So what we are going to look at, or what we are going to focus, is this piece, which says kubeconfig. So if you see this, the kubeconfig, and we are also going to look at the config. So we are going to look at the kubeconfig, and we are also going to look at the config of the kubelet itself. So first, let's see some details about the kubeconfig. So cat etc kubernetes and kubelet. So this is like any other kubeconfig. So that is why I said the prerequisite is to have some understanding of kubeconfig. So you know that the kubeconfig is going to contain details about the cluster, the username, the current context, and so on. So the kubelet is also like any other user. So if the kubelet has to issue something on the API server, it needs to have its own username, it needs to have its certificates, and it needs to have some information about the cluster on which it is going to operate. So which means that it needs to have details about the API server address of the cluster. So I'm not going to look at all the details of this, but you can explore it. I'm just going to grab I'm just going to grab something like this system node. Yeah, so there are a few details about this. So the username of the kubelet is nothing but system node master. So this is a special purpose username. So if you see the format of this, the first two components of the username is system:node, which means that this is a special user group. So when the API server sees it, it would give some standard permissions to the kubelet because it is part of the system node group. So it gives it a special node authorization permission using which the kubelet will be able to perform certain standard operations on the API server or the cluster. So that is why we need to give this prefix. This is already given. This is already bootstrapped by kubeadm. So we just need to know, even if we are doing it manually, we'll have to ensure that we give this prefix to the username. And the final entry is going to be the name of the node itself. In this case, it is master. So this means that it belongs to the node authorization group. So it would get all the permissions that a typical kubelet would need. So we didn't have to do any extra things such as role-based permissions, role-based access control is not required for kubelet. So if you give this username in this format, that should be more than enough. All right, so this is about the username. So, and this is about the kube config of kubelet. So there was one more entry in the service file, which is the kubelet's config itself. So I'm just going to look at the service configuration again for this purpose. So if you see this, this is the config. This is the config of the kubelet itself. So this file. Now we're going to look at this cat var lib kubelet and then the config. So this config is the configuration of the kubelet itself. So let's look at the contents of this file. Okay, so this is in YAML format. So it has got lots of things. It would have lots of things, lots of configuration parameters that a kubelet would have, and which would actually in turn affect the node on which the kubelet is installed. So we're not going to look at many of these. We will pick only one configuration parameter from this to keep things easy. So my choice would be the MaxPods parameter. So max pods, which means that the maximum number of pods that can be allocated on a node on which this kubelet is present. So we are right now on the master instance. So even in the master instance, you would need kubelet because there are certain special purpose pods that needs to run on the master. Even in production, or even if the standard workloads are only going to be present on the worker nodes, there are certain pods which also need to run on the master. So that's why you need kubelet on all the instances. So max pods is 110. Which means the maximum number of pods is 110 that could be launched on the master. All right. Now, let's see the configuration of the master node itself. So get node, and if I give master, and if I have to use the JSON path filter, I'm going to use the JSON path filter. It is a handy way of filtering things from the overall configuration. You could go section by section. It's very easy. So all you have to give is the first section, which is nothing but the spec of, we are not going to look at the spec. We are going to look at the status of the node. So I'm just going to say dot status, and inside the status, you would have something like allocatable, and inside allocatable section, there is something called as pods. So this is equivalent to the max pods configuration that you gave, that is there in the kubelets configuration. So if you give this and hit enter, you would see 110 there. Let me give one more echo so that it prints neatly. Yeah, so you have got 110 pods, so which means that the master node can allocate up to 110 pods because it is what it gets from the kubelets configuration. Now let's go ahead and change this configuration in the kubelets configuration file. So I'm just going to use nano for this purpose, nano, and I'm going to enter the file name, kubelet and config. Okay, and I need to search for MaxPods. Okay, so let me see, it should be somewhere here. Sometimes on the window that I'm using, Control W may not work because it's a browser-based window. So let me just go ahead manually, or yeah, I got it. Yeah, so this is here. Or we can also use editors like VI, and we could use the / and then search for the word that we are looking for. So now since we got it easily, we could edit it here. So 110 is what it has got here. So instead of 110, I can give something like 100, just to see if the change is happening, because that's the purpose of this video. Yeah, max pods is 100. Yeah, you could also experiment. You could give some 5 or 4, and then you can try to launch those many number of pods in the node, and you see what errors you get. Yeah, so I just saved it. Why? Let me see if the change is present on the file. Let me just double check it by using the cat command, and then I'd like to grep it. I would grep for, so it's case sensitive. Okay, yeah, so it is 100, so the change is there. And now we need to restart the system for the change to take effect, because the master would still show 110. So if I use the other command on the master, I would still C110 because the change has not taken place. For the change to take effect, I will have to restart Kubelet. Since Kubelet is existing as a service, I would use the system control command to restart the kubelet like this. And when I restart it, okay, when I restarted the node, the master may go to the not ready state for a few seconds. So we may have to be a little quick to see the status. Yes, it is not ready now. It is not ready. It's still not ready. It may take some time because we have restarted it. Now it is ready. So it has taken a few seconds to go back to the ready state. And now we are going to use the same old command to see if the change has taken effect and if it shows up in the master as is. So the same command using the JSON path, we get 100. So that is how we saw where the kubelet is existing and where the service configuration is present, because in a typical kubeadm based cluster, kubelet is going to exist as a binary and in turn as a background service for which we need to have some configuration for the service itself. And in the services configuration, we saw where the kube config for kubelet is present. We also saw where the config for the kubelet is present. And when we changed the config, we saw that change reflecting on the master. Hope this video was useful and we thank you for watching it.